Good afternoon, and thanks for coming to listen to me talk about the voting, the rating API that we built for Devoxx. It actually, when I put this talk in, it was going to be the voting API for Devoxx UK. Unfortunately, it isn't actually running in the thing. It was re-implemented by someone else and everything. So what I'm talking about is all old news, but it's the whole process of what we went through to do it. I think is kind of interesting. So a little bit about me. So I work for Adaptivist, who build stuff, and I've got kind of a passion for programming languages and experimenting with them, building things. I've done a couple of Devoxx projects before. We did a interactive digital signage with the Connect, so you could go up and interact with the signage, and the Vote API, and all the code is available if you want to go and check that out. So it's a quick look through what we're going to look at. We're going to look at why we needed an API, and then have a look at some of the implementations that we went through. So first, why do we need voting or rating as part of a conference? Well, feedback is the key thing. So when you're writing code, you develop like a really fast feedback cycle. So it's exactly the same when you're putting on a conference. You want to know, what talks are good. What did people enjoy listening to? What didn't they? So feedback is the answer, because good feedback leads to improvements and things. So why do we build an API for it? Well, the answer is kind of microservices, and the fact that we needed a whole load of other things to be able to interact with it. So these are some of the mobile apps, and you need to be able to input ratings from those. And we need a way of having one source of truth for all of the voting or the ratings that get applied to talks and to speakers. So next up, what did we actually build? Well, we needed a way of being able to capture votes from many different devices. We needed to do things like remove duplicate ratings. We need to only open voting when the talk has begun, so you can't vote for it beforehand. And then we needed to be able to report on all of this information that we have. So what are the top 10 talks in the different categories, and that kind of things. And then we also needed kind of more detailed reporting for after the conference, so you can see, who was popular. Was there anybody in particular? Were they in the wrong rooms? What topics do people want to be able to listen to, and things. Also, it needs to pull the information from the CFP app, where all the speakers input their talks and ideas in there, and then the schedule is going to pull out there. So it needs to be able to interact with that, and also some of my requirements. It needed to be really fast. It needed to be reliable, so I could be at the conference without having to debug it or anything like that. And I wanted to have some fun writing it. So we looking at the implementations. I did multiple implementations for different iterations of the conference. So all of them have they're common platforms, so they're all deployed to Heroku, and they're a JSON REST API. So what I thought, well, what's the perfect language to write something for a Java conference, which is clearly Golang. So all the cool kids have been using it. It's massively popular for some open source tools like Docker and like HashiCorp are kind of really going to gone into Docker in a big way. So I'm not a Docker expert. I'm very much a novice, and this was my way of kind of exploring Go as a language. So first off, here's some Go code, and that's Hello World in Go, which is fairly simple. Something a little bit more complex is this, and this is actually the REST API that we built. And so I can give a little bit of detail here. So the highlighted area, the black area, we were able to add in middleware, and that's just a function. We're able to define our routes as well, and that's pretty clear. I think the code is reasonably self-explanatory. And then to handle each of the endpoints, again, we have a function. Do that. So rather than going into too much more detail in the actual code and things, let's have a look at what did I learn using Go to write this thing. So Go is a really simple language. There's not a lot to it. The contracts are very simple. It's really, really nice to deploy. You build a single fat binary, and you deploy that, and you run it, and that's it. There's nothing more to that. The dependencies are very few. It's also really fast to compile. Has great concurrency constructs. So you might have seen the kind of Go routines and those sort of things which make writing asynchronous concurrent code very, very simple. There are thousands of libraries. I mean, the ecosystem is really vibrant, and the tools are good. So one of the tools, Go format, means that all Go code looks the same, regardless of who written it. You run it through Go format, and it makes it really easy to pick up these if anybody's written it. And there's some things like as part of the tooling, like unused code is a compile time error. So if you leave something unused, then that's a you don't have those littered around your code. It kind of promotes good practice. And it's got types and interfaces, and the type system is very simple. It kind of favors composition over inheritance. So there's only ever a single level of inheritance and things like that. So what was hard about Go? The dependencies I found really difficult. So coming from the Java ecosystem, where you declare them and you POM, and you can get all your dependencies out very, very easily. Everything's source based. It's very, very difficult to work with coming in as a newbie. I like functional programming, and Go doesn't at all. And error handling is strange. A bit more on error handling in a minute. Also, Go format, it uses tabs. I'm not a tabs person. Spaces, and the type system isn't really strong enough. So you end up using this all over the place, which is basically it's the version of Java's object, because there's no generics and things. So I mentioned error handling. Error handling in Go kind of obfuscates what's actually going on here. So this is the code to log a vote, and the vote is in that if statement, and this is the kind of the idiomatic way of doing error handling in Go, as far as I understand it. And this is another way. So this takes advantage of multiple return types, but you always have to have this if error, and it feels very clunky. Good things. What I was really looking for is maybe even exceptions or an optional or things. This doesn't seem modern. So what is Go good for? It's good for large teams because of the tools, and everything's always the same, and things. I think it worked really well for large teams, big open source projects, and that kind of things. It's also really good for command line tools, as you see with like Docker, for example. But it is frustrating if you're used to something a little bit higher level, a little less systems. Right. So let's have a look at something different. So I said I'd implement it in different languages. So the next one is Racket. So I'm going to show you. Does anybody know what Racket is? We've got two. So Racket's a Lisp. I love Lisps. And Racket's is no ordinary Lisp. It's kind of a language for building other languages, and it's very much batteries included. It's vast as a language. So this is Hello World. That's where you always start. And a little bit more interesting is a web service with Racket. So we specify the language, which is this Insta web service, on a function, and then the function returns a HTML with the body set to Hello World. It's kind of pretty simple. You can also do things like enable laziness in Racket. So this is Fibonacci. in Racket, and you can do things like implement Java in Racket. So this is Racket, and it's Java. And it's really it's a really flexible language. Things. So Racket was Racket's awesome. It's got everything I needed to do any of this stuff. The tooling is awesome. Lisps are great and other things, but Lisp isn't everybody's thing. So in comparison to the implementation of the voting API on Racket and Go, there's significantly fewer lines of code. It was a lot more fun to write, actually, than Go. Lots less headbanging and things, and it's really expressive. But it was pretty much an order of magnitude slower than the Go implementation. So up next, Groovy. Groovy built on Ratpack. Can I show of hands of people know of Groovy and things? Okay, a few more. So Groovy is a JVM language, which is optionally typed, dynamically typed, expressive, great for DSLs, metaprogramming, functional programming, basically all the things. Like you can do almost any kind of programming in Groovy. Hello world in Groovy. Things. But the interesting thing about this is actually Ratpack. So Ratpack is a set of libraries for building modern HTTP applications. Kind of it's built on reactive principles, follows Java 8 things, and it's asynchronous by default. This here is a complete Ratpack server. All you need to do is run Groovy Ratpack Groovy, and this will get you a web service with a hello world. The equivalent, so you don't have to write Groovy. The equivalent Ratpack service in there, that's that in Java. So kind of the interesting thing about this, the voting API in Groovy is that it was kind of in between Racket and Go in terms of lines of code. There was much more of a model needed for Groovy than there was for Racket, but kind of less than there was for Go. Groovy is kind of my comfort zone. It was pretty fast. It was kind of similar performance to Go, but it was difficult to compare accurately because the Go implementation was using Postgres and we were using CouchDB for Groovy. Now, I promised 4 languages. I ran out of time. And I ran out of energy, so I was going to do a Haskell implementation or OCaml or Elixir, because I think that would have been interesting, but I really ran out of time. So the 4th language, which is kind of a fudge, was the simple user interface that we built. Just going to skate over because it's not really that interesting, except we implemented it in React, which felt very nice, particularly for someone who's got a functional programming bent like myself. The immutability was really nice, and the flow of data works really well. So kind of summary, I'm a Lisp weenie. Lisp is great, and Racket was the most fun to implement. That was one of my requirements. Was that it was fun. Racket was the one that hit the hit that requirement best. Go was by far the fastest. Although Groovy and Ratpack were kind of close, but it was also pretty much the easiest to deploy. There was no dependencies, no JVM needed, none of that things. It was very simple to deploy. But Groovy and Ratpack were really I really liked doing that. And would choose Groovy and Ratpack to build other similar systems. But one of the key things it's microservices are just microservices, and you've got an API. It's easy to write them, even in a Lisp. You can write microservices in any style. Really, Ratpack is really awesome. It's a really well written system. It's got some really nice ideas in it, and I'd encourage you to go and check it out. So one of the things that going through this process has taught me is that you can use microservices to kind of experiment with different ideas and different systems in your overall application. If it's built up of microservices, you can say, well, actually, why don't we go and experiment with closure over here? So how is this? And then if it doesn't work out or whatever, then we can go and replace that one bit. But it's a fairly small, distinct area which has got very nicely defined contracts, because it'd be just a REST API or whatever it happens to be. So I'm going to finish up with a shameless plug. We're hiring at the moment. If you want to, if you think you're a senior engineer, you want to write Groovy all day, then yeah, come and talk to me, because we're currently hiring senior engineers. And with that, I think I'm out of time. So thank you very much.